In this presentation on relations and functions, we are going to discuss that how to count the number of functions depending upon their types. So first of all, we are going to count the total number of functions from a set A to B. So suppose we are saying that we have the set A which consists of m elements and set B it has n elements, and we want to calculate the total number of functions. So if we talk about the first element of the set A, suppose we are considering the sets in this form. The set A, it has the elements 1, 2, 3, so on up to m, and set B, it has the elements 1, 2, 3, so on up to n. So these are the two sets we are talking about. This is set A and this is set B. So we are saying that this first element of the set, that is we are talking about 1, it can be mapped to 1, 2, 3, 4, 5, so on up to n. The situation it is shown over here, that this first element, it can be mapped to any one of these n elements. So there are, what we obtain from this is, there are n ways to map this first element 1. Similarly, the second element 2, it can be mapped in n ways to any one of these n elements. Likewise, if we continue, we are talking about this element m from the set A. It can be mapped to any one of these elements 1, 2, 3, so on up to n. And we are saying there are total n ways. Now the total number of functions that we have, we are saying 1 can be mapped in n ways, 2 can be mapped in n ways, 3 can be mapped in n ways. Likewise, we have m, this last element m, it can be mapped in n ways. So we are saying that n is multiplied m times. So answer we have it is n raised to the power m. So the result we obtain is the number of possible functions from A to B is n raised to the power m. Now next we are going to count the number of 1-1 mapping. So suppose we are considering that we have the set A and B, and this set A, it has m elements and set B has n elements. Now suppose the first element of the set A, it is x1. So if we look at this condition over here, we are saying the first element of the set A, it can be mapped to any one of the n elements of the set B. It can be mapped to any one of these elements. So in this particular case, we are considering that n is greater than equal to m. So we are saying that this first element 1, it can be mapped to any one of these n elements. So what we obtain, x1 can be mapped, or x1 can take n images. Now suppose x1, it is mapped to one of the elements. Now if we map this second element to, how many elements we are left over here? It is n minus 1 elements. We are saying that 1 is mapped to 1. How many elements we are left with is, we are left with is n minus 1 elements. So we are saying that x2, it can be mapped to, or it can take n minus 1 images. So continuing in this way, we are saying x3 can be mapped to n minus 2 images, because if this second element is mapped to one of the elements, then we are left with n minus 2 elements in the set B. So likewise, if we continue, we are saying that xm can be mapped to n minus m plus 1 images, and the total number of images we obtain by multiplication theorem, we are having it is equal to n into n minus 1 into n minus 2, so on up to n minus m plus 1. And this value, it comes out to be equal to npm, where we are saying n is greater than equal to m, where we are having the value that n is greater than equal to m. And this value, we can also write it in this form. We are talking about this value. We are saying when n is greater than equal to m, we can write this value npm as ncm into m factorial. So these are the total number of 1-1 mappings from the set A to B. Now next we are going to sum up these properties again. So first thing we have noticed over here is that the total number of functions, it is n raised to the power n. Then we are saying the total number of 1-1 functions. The condition we are considering is n is greater than m. The total number of 1-1 functions we have, it is ncm into m factorial. And the case if we are talking about n is less than m. Suppose I am talking about there is the function, the set x, it has elements 1, 2, 3, and the set y has elements a and b. Now suppose this 1, it is mapped to a, this 2 is mapped to b, then 3 must be mapped to one of the two elements a or b. So we are saying that there cannot be any 1-1 function if we have n is less than m. So we are saying that how many 1-1 functions are there? There is no 1-1 function, 1-to-1 function if n is less than m. So we have total number of functions, it is n raised to the power n, and 1-1 functions, they are in this form. So what we obtain from this is that the total number of many 1 functions, that is equal to total functions minus 1-1 functions. So total function is n raised to the power m, and we are subtracting this value. So this is the number of many 1 functions. This is the case when n is greater than equal to m, and it is equal to, we have total function is n raised to the power m, 1-1 function is 0. So subtracting these two values, we get it is n raised to the power m when n is less than m. So these are the total number of many 1 functions. Now next we are going to count the total number of constant functions. So constant function, we mean to say that we are having the two sets x and y. We are having two sets x and y, and we are saying constant function means that all the elements of this set x, they have the same image in y. It means we are saying that this element 1, if it is mapped to 1, then all other elements, they are also mapped to 1. If this element is mapped to 3, then all other elements are mapped to 3. So how many options are there for this first element 1? There are total n options to choose from. So we are saying that the total number of constant functions that we can have, that is equal to n. That if we have fixed for this one, if we have fixed the image for this one, then all other elements will have the same image, and there are total n options to choose from for the image of this first element 1. Now next we are going to count the number of into functions. So to count these functions, we are saying suppose we have two sets a and b such that a has m elements and b has n elements, and we are considering the case that n is less than m. So we consider a set over here, that is the set of all functions from a to b. Now from this set we can consider another subset of this set, that we are saying it is q, and an element, it belongs to q. If we are saying, we are constructing another set over there, we are saying ai, that is equal to f belongs to q. We are saying that any function f, it will belong to the subset q if I is not in the range of f. So to understand what we mean to say, we are going to consider an element over here. Suppose I am talking about a1. So we are saying that any function that will belong to the subset q, if we have 1 is not in the range of f, it means we are considering all those functions. We are talking about all those functions for which 1 is not in the range of f. So we are saying f belongs to Q such that 1 does not belong to range of f. This is representing the set A1. We are talking about this is the collection of functions for which 1 is not an image of any element of the set A. Similarly, if we talk about A2, we are saying that is equal to f belongs to Q. We are talking about A2 consists of those functions f for which 2 is not in the range of f. So how we can consider this thing? We are saying that we are talking about all those functions. We are talking about all those functions for which 2 is not an image of any element. So if we continue in this way, what we obtain is, we are saying that union ai, I is equal to 1 to n, that is equal to a1. A1 is those functions for which 1 is not in the range of f. It means those functions for which the image is not 1. Then union those functions for which image is not 2. Then union so on up to those functions for which image is not equal to n. So if we count the total number of functions in this form, we are saying what this term is representing. It is representing those functions for which 1 is not the image, 2 is not the image, 3 is not the image, and so on. So if we count the cardinality of this set or count the number of elements in this set, we will obtain the number of into functions. Now, to count the cardinality of this set, we are saying this is symbol for cardinality of the set union I is equal to 1 to n ai. We are saying this is equal to, by set theory we know that the formula we have, it is equal to sigma sum I is equal to 1 to n cardinality of a1. It means we are talking about what this term represent. It is representing cardinality of a1 plus cardinality of a2 plus cardinality of a3, so on up to cardinality of an. It means we are talking about, we are counting the functions for which image is not 1, image is not 2, image is not 3, so on up to image is not n. Then we have to subtract from it. We have to subtract from it this term. What this is representing, if I am talking about the first term, if I am talking about a1 intersection a2, it means I am talking about those functions which do not have image as 1 and 2. And likewise we will continue. This result we are getting from the set theory. We know that if we have union, then we have the number of elements, they are given by this formula. Now to calculate the number of elements in this first term, we are going to calculate the number of elements in this first term. We are saying that we are considering the set over here in this form, and suppose we are saying we are considering the elements in this way that n has no pre-image. We are saying n has no pre-image. So how many ways are there? We are saying there are nc1 ways to choose one element out of these n elements. What we mean to say is, we are talking about a1 plus a2 plus a3 so on up to an. We have to choose one element out of these elements which is not an image over here. So how many ways are there? We have to choose one element out of these n elements. So there are nc1 ways to choose the one element out of these n elements. And how many elements are remaining now? We are saying the number of elements that are remaining over here, they are n minus 1. And from these n minus 1 elements, we can form, we are saying out of the remaining n minus 1 elements, we can form n minus 1 raised to the power m functions. Similarly, when we are talking about the second term, we are considering the case in this way. What we are saying, that first of all we have to choose any two elements out of this. We are talking about this set, we have to choose two elements. Suppose I am choosing the element say 4 and n, or I can choose the element say 1 or 2. I can choose the element say 2 or 3. So how many ways are there to choose two elements out of these n elements? The total number of ways, we are saying that there are NC2 ways to choose two elements out of these n elements. Now suppose we have chosen two elements. Say we are saying we have chosen this element 4 and we have chosen this element n. So how many elements are remaining now? There are n minus 2 elements. And with these n minus 2 elements, how many functions can be formed? We are saying that out of the remaining n minus 2 elements, we can form n minus 2 raised to the power m functions. So what we are saying, the values we are obtaining over here, this sum we are saying, what we have obtained, the value of this first term that we have, it is equal to, we are saying we can first choose one element out of these n elements in NC1 forms, and then from the remaining n minus 1 elements we can form these many functions. For the second term, we are talking about this second term, we are saying we have to choose first two elements. To choose two elements, we are saying how many ways are there? There are NC2 ways. How many elements are left? We are saying we are left with n minus 2 elements. We are left with the set having the elements 1, 2, 3, then 4 is missing, then 5, 6, 7 up to n minus 1. And how many functions can be formed with n minus 2 elements? It is n minus 2 raised to the power m. So we are having the value over here, it is this. So likewise, if we continue, we will have the general term, or the last term we have, it is minus 1 raised to the power n minus 1. Then we have n minus 1 into 1 raised to the power m. In the end, we will have only one element in the range set. So these are the number of into functions that we can form. Now next we have is the number of onto functions. So that will be given by the total number of functions minus the number of into functions. The total number of functions we have, it is n raised to the power m, and into functions we have seen they are given by this formula. So we can write this value in this form. So this formula, it gives us the total number of into functions that we can have. Now to sum up the things, we are saying the total number of onto functions when n is less than m, they are given by this formula. And the total number of into functions when n is less than m, they are given by this formula. Now next case we are considering when n is equal to m. We are saying we have some condition in something like this. We are having 5 elements in the set A and we are having 5 elements in the set B. And if we want the function to be an onto function, it means that every element of this set B, it should have a preimage. We are saying this is set B, this is set A. We are saying every element of this set B should have a preimage. It means that no element in B, it can have two preimages. We are saying that when n is equal to m, what we obtain from this condition is when n is equal to m, then no element of B can have two preimages. So in how many ways this first element can be mapped? If we are having m elements over there, we are saying it can be mapped in m ways. Suppose this 1 is mapped to 1. Now this 2, it cannot be mapped to 1. We are saying for the function to be onto, now this 2, it cannot be mapped to 1. It should be mapped to one of the remaining elements. It means that how many options now we have? We have m minus 1 options. Then this 3, it cannot be mapped to first two elements, these two elements. How many options we are left with is m minus 2, and continuing in this way, we are saying the last element, we will have only one option. So what we obtain from this is that when n is equal to m, the number of onto functions that we can have, it is equal to m factorial. Next we have is the third case, it is when n is greater than m. So we are saying when n is greater than m, we are considering this example over here. By the definition of function, each element in the domain can have a unique image over here. It means that if all these elements in the domain, they are mapped, then we are always left with an element in the codomain. It means that we cannot find an onto function in this case. There is no onto function in this case. It means we are talking about that all the r raised to the power n functions, or we are saying all n raised to the power m functions that we have, they are into functions. Next we have is the total number of bijective mappings. So we are saying that if there is a bijective map between two sets A and B, then it means it is both 1 1 and onto. It means every element has a unique image and a unique pre-image. It means that both the sets will have the same number of elements. So what we obtain is that if n of A, that is number of elements in the set A, is equal to number of elements in the set B, that is equal to m, then the number of bijective functions that we have, it is equal to m factorial. So these are the total number of bijective functions that we have. So to understand this situation, we are saying that they have the same number of elements. We are saying they have elements 1 2 3. The second set, it has elements A B C. So in how many ways this one can be mapped? It can be mapped in 3 ways. If this one is mapped, say to B, this one is mapped to B, then for 2, for mapping this element to 2, how many elements are left? How many options are left? 2 options are left. So we are saying it is into 2. Now suppose this element 2, say it is mapped to this A. Then for C, how many? For this element 3, how many options are left? There is only one option left. The answer we are getting, it is equal to 3 factorial. So similarly, we are saying if the number of elements in A is equal to number of elements in B is equal to number of is equal to m, then the total number of bijective functions we have, it is m factorial. Now the next question we have is this set X is given. It has elements 1 2 3 4 5 and Y has 6 elements. Now we have to calculate the total number of functions. First of all, we are calculating the total number of functions. The formula we know, the total number of functions, it is given by 6 raised to the power 5. So the answer is 7776. Next, we have to calculate the total number of 1 1 functions. So it is given by the formula 6c5 into 5 factorial. On solving this, we get the value, it is 6 factorial, that is equal to 720. Next is the total number of many 1 functions. So 1 1 functions, number of 1 1 functions we have 720. Number of total functions, it is 7776. So number of many 1 functions we have, it is 7056. Next is the total number of constant functions. So it is given by the number of elements in Y, that is equal to 6. Next is the total number of onto functions. So we can see that the number of elements in Y is greater than number of elements in X. It means that there cannot be an onto function. There is no onto function. Now, there is no onto function. It means all functions they are into functions. So the total number of into functions we have, that is equal to 6 raised to the power 5 minus 0, that is equal to 7776. So this is how we can directly use the formulas to calculate the number of functions between two given sets. Next question we have is find the number of surjections from the set A to B, where A is 1, 2, 3, 4, it has 4 elements, and B is AB, it has 2 elements. So clearly the number of elements in A is greater than B. So the number of surjections from A to B, it is given by this formula. So if we substitute the values over here, for R is equal to 1 and R is equal to 2, we are saying the answer we obtain, that is equal to minus 2 plus 16, that is equal to 14. So we have directly substituted the value in this formula to obtain that the number of surjections from this set A to B, that will be 14.